what you should have discussed already in class is this graph right here is not a true graph depicting the number of days and the number of smoothies relationship. Okay, so we need to find, is there a correlation between the number of days and the number of smoothies? So this graph looks like, oh, that's a nice true positive correlation, but then your intervals, here is a 1, and then from 4 to 6, that's an interval of 2. From 6 to 9, that's an interval of 3, and then we go back to 1 and 2. So this is not a true number line. This cannot be an x-axis. And then this cannot be a y-axis because we have an interval of 3, an interval of 2, an interval of 5. These intervals are not all the same. What this person who made this graph here just used these numbers as our x's and our y's without taking into consideration that these have to be equal intervals. So this graph is not useful. So what we're going to do is we're going to get a little bit of information together so that we can use this graph in order to predict, kind of like what we did in a previous lesson. So this is lesson 232. We are scaling graphs. Okay, so we're going to take this data and put it on a table first. So this is the number of the day and smoothies sold. And this will help us to organize for our graph. So day 3, they sold 3 smoothies. Day 4 is 5. And then 6 is 10. 9, they sold 20 smoothies. 28 smoothies. And 38 smoothies. Okay, so using this data, we need to realize, well, which ones are x and which one is our y, but they kind of already told us the number of day is the independent variable and the number of smoothie is our dependent variable. So this is the x and this is the y. Okay, so for our graphing purposes. So now we're going to make a graph. So let's go ahead and set our x and y axes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to go across 10. This is our x and y axis. And always label. We always label our x and y. This is the independent variable. The number of smoothies will depend on the number of day. And this is the smoothies sold. All right. So we're trying to figure what kind of axis can we use? What kind of information do we need in order to be able to predict for day 20? Okay, so this is our goal. This is our what we're looking for. Day 20, there's going to be how many smoothies? Okay, so as we're going to graph our data, just keep in mind that these are all ordered pairs. So those are all locations on the graph on this coordinate plane. So what kind of axis can we use? All right, so what you should have realized is we need to show day 20 on this axis. So what can we do to spread out our data? Remember, on a previous lesson, we talked about how we can spread out the data to make it easy to read. And if we want day 20 to show, it's got to be somewhere around here. So a good way to do is, since there are 10 intervals here, we can count by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So now this axis, we're counting by 2s. I only mark the 4s just to kind of make it a little bit more spread out, visually appealing. So now we can see day 20, and these are all even intervals. And if I have my data all spread out from day 3 all the way to day 20, it will all show on this along this x-axis. So we're looking at our number of smoothies sold, and we're trying to figure, well, how high do I need to go on this? Okay, so if by day 12 I have 38 smoothies, I don't want 38 to be up here towards the top because I'm going to need to predict for day 20. So we know it's going to be beyond 38, and we figure, well, it might be maybe another 20 smoothies or so, because on day 10 it's 28. So let's use a y-axis interval of maybe 5s. Okay, so that would give us 10, 20, 30, 40, 50, and let's see if that's enough. If not, we can always adjust our axis. So now what we're going to do is we are now going to graph all of these ordered pairs. Okay, and just remember that this day 3 smoothies means I'm going to graph this point. This means I'm going to graph that point, and so on. All right, so our first one is 3, 3. Here's 5 on our x-axis. Here's 2, 3, 3. Okay, so somewhere right there. 4, 5. 6, 10. 9, 20. 9, 20. 10, 28. 10, 28. 12, 38. 12, 38. And now this is the last of our data, and remember we need to go to 20. Now, well, one thing we talked about in a previous lesson is, where do we start this graph? So are we going to start here where our data starts, or are we going to start here at the origin, which is 0? And we need to consider, well, would I be able to put 0, 0 on this graph? On day 0, is it true that I will sell 0 smoothies? And the answer is yes, I will sell 0 smoothies on day 0. So this is going to be where I start that graph. And now I need to draw a line of best fit to go kind of through the middle of my data so I can see what would happen on day 20. So I need to make that line go all the way to day 20, and then that will help me to predict. So I think my line of best fit would probably go in the middle of my data, probably here. So let me draw that line. This is my line of best fit. And then I make sure, okay, that kind of looks like it's going through the middle of my data, and it's an upward trend. So now I can see, okay, day 3, somewhere around the line. Day 9, somewhere around the line. And all these are hovering around the line, which means I can use the line as a point of reference. Okay, so now looking at that data, does it look like we can predict where day 20 would be? So we look at day 20, and we just kind of go up here, and it looks like day 20 hits the line there, so my data is going to be somewhere around there for the number of smoothies according to this line of best fit. And I go across, and it looks like I'm going to sell about 50 smoothies, because that's my dependent variable. Approximately, this is approximate, 50 smoothies. Now, if your line of best fit is a little bit different, okay, so let's say your line of best fit goes a little bit this way because you see the middle of the data a little bit different. It's not going to be too far off. It still says that you're going to sell about 43, 44 smoothies, which is close enough to 50 smoothies, enough for that business to be ready to sell those smoothies. So this is what businesses use to project. By the end of the year, I'm going to sell this much. By the end of the month, I'm going to sell this much. And so they actually use procedures like this in order to run a business. The next question in our book, which is The table at the right shows the time it took 5 different students to get to the mall and how far they traveled to get there. So distance and travel time. So what we're going to do is just kind of practice and see if we can do all this over again on our own to find out how can we best tell where the line would be in order to predict. Okay, so let's show this data in a nice readable fashion. Make our table right here. So we are traveling to the mall. Okay, so we take our distance and our travel time. Okay, so our distance is going to be in miles, and our travel time is going to be in minutes. Okay, now which one would be our independent and our dependent variable? Okay, so x is always our independent variable, and y is always our dependent variable. You might have heard these terms from a previous class. Okay, so we need to decide which one is x and which one is y. Does the distance that someone traveled depend on the travel time, or travel time depends on the distance from the place? Now, in this case, we're going to use the distance as the x, which kind of determines the travel time. So this is the x, and this is the y. How long we travel depends on how far it is, dependent. Okay, so here are our distances. We have 4.1 miles away. It took them 13 minutes. 1.7 miles away, 7 minutes. 3 miles is 10. 2.2 is 8. And 0.5 is 3. Okay, and using this data, we might be able to tell, let's say that we're trying to find out how long would it take somebody who is 5 miles away how many minutes would it take them to travel? Okay, and obviously we're going to use this to predict. Okay, so let's set up our data on this graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, always label. This is distance in miles, and this is travel time. Which is in minutes. Okay, so let's find an appropriate scale. So what you might have come up with is, if we want to look for a distance of 5 meters, or 5 miles, we have 10 intervals here, so it might be a good idea to count by half a mile. Okay, so this would be 1, 2, 3, 4, 5 miles. Okay, so now we can find 5 miles, and it'll be a nice spread out graph. So our travel times, look at this, it goes up to 13, so how far might we want to put it? So maybe we want 15 to be up here. So maybe we could go by 1.5. So 3, 6, 9, 12, 15. So now let's start graphing these points and then see if we can make a line of best fit. And then where will we start? If the distance is 0, will we travel 0 minutes? That is true. So we're going to start this graph at 0. So go ahead and graph those points. So what you should have is 4.1, 13, 1.7, 7, 310, 2.28. One half 3. Okay, so here is our data, and let's draw a line of best fit. So we're going to go right in the middle of our data, which might be here. Okay, notice how I made that point on the other side to kind of give myself a point of reference. And that looks like it's our line of best fit. So according to that line of best fit, how far away for 5 miles? Okay, so we see 5 is right here, and it looks like it goes a little bit above our graph. So what number would that be if we were to estimate this? Okay, so 12, 15, this would be 18. So I would say approximately 17 minutes.